Hi everyone, welcome to our short presentation for CP3403 data mining. My name is Royce Blackburn and I'll be talking briefly about our selected dataset and the pre-processing we performed on our data. Our dataset was chosen from Kaggle.com and contains 3 years of real estate data for the Greater Melbourne area. It contains a variety of numeric, nominal and string data types, initially containing 34,858 instances and 21 attributes. We chose this dataset for several reasons. Firstly, it contained an amount of data that we felt our computers could comfortably process without undue computational delays. Secondly, it was missing a sizable portion of data in some attributes, ranging from 20 to 60%, which allowed us to explore a variety of pre-processing techniques. Pre-processing the data took place in several stages. Initially, Python and the Python library pandas were used to import and export the data. Several attributes were removed at this stage, as they were either unnecessary or simply missing too much data. Custom Python algorithms were then written to replace the missing values in the data, and instead of using the average values for the whole dataset, instances were given the mean or median values for their suburb or type. Next, dbScan was used to remove noise from our data, and finally, k-means was used to cluster our data into 5 clusters. From here, some preliminary knowledge was gathered, and we moved on to classification. Here's Christian to tell you all about it.
Classification in data mining is used to learn from observations in a dataset and predict labels of the unseen observations. For our project, we decided to try and predict how accurate the pricing would be for other or future datasets of this type and determine which hotspots in Melbourne would be most accurate in the future. After all the initial pre-processing and clustering, we decided to bin the pricing into 3 separate categories: low, medium, and high pricing, do some further dimensional reduction for attributes that were not relevant, and create data subsets with systematic random sampling. For this, we decided to go with 3 different methods: naive Bayes, J48 decision tree, and simple logistic. We decided to go with naive Bayes and J48 as they are commonly used in data mining and have fast computational times while still giving accurate results. We also chose simple logistic as it is a combination of using both linear regression and decision tree methods. Based on the results, we can see that naive Bayes performed quite poorly in accuracy to classify the instances, while J48 and simple logistic performed quite well. We can also see that the optimal data size to use these classification techniques was at 66% of the overall dataset, which was around 20,000 instances.
Hi, I'm Vanessa, and I'll quickly talk about the patterns and findings we got from the Melbourne housing data. So as seen on this image, the properties in northern and western Melbourne are far more cheaper compared to east, south, and central Melbourne. While on this diagram, an overall decrease of average sales price is noted. However, it can be seen that there were slight increase in average sales prices in Q4 in every year except in 2018. So this part and this section. So clearly the trend towards loss in property value in every cluster of our data set has been detected and would likely require further investigation to determine if this trend is likely to continue or if we are at the bottom of a trough and prices are likely to bounce back. As for the classification method findings, naive Bayes has a significantly lower accuracy compared to the other 2 methods. The J48 classifier has the highest accuracy for the data subsets, giving the most accurate result for predictions. It is evident that the results seem consistent in that there is around 77.51% that any data would be put into this model will be correctly identified. So this wraps up our presentation. Thank you.